This video is a basic walkthrough of nodes in OpenRoads, also known as SUDA cells, how they operate, and how they can be modified within a cell library. The drainage and utilities feature definitions are defined by these 3D and 2D SUDA cells to define how they'll appear in plan view, in profile, and 3D views. Drainage and utilities nodes will use 2 to 3 cells to define how they look. The first they will use is a 2D cell used for plan view, and they will use either a 3D top and a 3D bottom, or just a 3D bottom. Nodes such as catch basins, manholes, or other boxes that adjust in height will have a 3D top cell that is stationary and a 3D bottom cell that varies in height and depth. Other nodes such as end sections or head walls will not vary, and so they only need one 3D cell, and the 3D bottom cell is used in that case. Because multiple cells are used in the drainage and utilities feature definitions, drainage and utilities needs to know some information to place these models within a 3D model. It needs to determine a placement point so that it can place it correctly in 2D as well as elevation wise in 3D. It needs to know how to align the object as well as its rotation point. It needs to determine invert elevations, or in other words the depth of an object, and it needs to determine connection points. These are referred to as connection regions by drainage and utilities. These connection regions are for conduits, which are typically drainage, but also can be used for other utilities as well. To begin, you'll need to create a cell library or copy and modify an existing cell library as needed. You can see here that all of the different cells are actually separate models within the cell library. These 3D cells are bottom cells for end sections. These are bottom cells for other structures such as manholes and catch basins. These are plan view cells. And finally, there are some top cells for manholes and inlets. You can see here it's important the naming convention so that it's easy to reference into your feature definition library to avoid any confusion in referencing these SUDA cells. To begin, it's typically easiest to start with a plan view cell and copy and modify as needed. If you have a cell library, you can copy, otherwise you can create a new model, and this is a new cell. If I were to copy it, I would just rename it and its description and click OK. After you've created your model or cell, you'll want to draft in how you would like your 2D cell to be represented. So you'll want to put in your line styles, levels, and weights according to how you would like to see it in 2D view. There are overrides for this via element templates. However, in plan view in particular, they don't always work correctly, so it's best practice just to establish how you want it defined in 2D view in the cell itself. To create a 2D plan view SUDA cell, you need three things. You need a placement point that tells it where to place the 2D cell. You need an alignment point that aligns the 2D and 3D cells, and you need an alignment line that acts for rotation and orientation to an alignment or other references you may place it using. Now I have my element properties opened up so you can see the properties of the SUDA information. It's critical that all three are present and they're not duplicated or they're not missing any for it to be correct. This is the alignment point. You can see critically the line style is 3 and the class is set as construction. It's in red. As I look at the next one, this is my placement point. The line style is 4 and it is the construction class. And then lastly, I have the alignment line and it is a line style of 3 and construction class. Lastly, you'll notice the geometry starts at 0, 0, 0 to make sure that I'm aligning correctly with my 3D cells.